Welcome to the problem-solving video. My name is Fernando Diz, and I'm the Whitman Associate Professor of Finance at the M.J. Whitman School of Management at Syracuse University. Today we'll go over problems that belong to level 2 derivatives. And so why don't we just go into a problem and I'll let you know how we're going to approach solving them. The problem we're going to talk about now is a problem regarding futures, and it's stated as following. The current price of heating oil for immediate delivery is 69 cents a gallon. Let's consider financing as the only carrying cost, and that financing is done at RF, which is the risk-free rate, and the risk-free rate is expressed on an annual basis. So this is a 5% per year basis. So we have the price for immediate delivery of the commodity, which is 69 cents per gallon, that's heating oil. And we have assumed that the only carrying cost is financial at a rate of 5% per year. So the first question will be, what should be the futures price of heating oil for a contract that expires in 60 days? So what the question is really asking you is what the theoretical futures price, or what we call the no arbitrage or fair value futures price is for this futures contract. And the skills you need to have to solve these kinds of problems are the following. One, you need to be familiar with notation. In the exam, some notation may appear that you need to be familiar with. And then you need to be very familiar, very knowledgeable about how these contracts are priced. So let's go over some of the notation first. Let's start out with the first piece of notation, and that is cap T. That denotes the time to expiration of the contract. And the way it is measured is as a fraction of the year. So for example, if the contract has an expiration of 90 days, T, cap T, is 90 days divided by 365 days, or 0.2466. Now, I need to remind you that for different contracts, the convention for the duration of the year is different. For example, T-bills, or T-bill futures and Eurodollar futures, have a 360-day year convention. For most other assets or commodities, the year convention will be 365 days. So if you just remember that for T-bills and Eurodollar futures, the convention is 360 days, you'll be fine. Let's move to the second piece of notation, and that is capital S sub naught, or sub zero. And that is the cash price today for the underlying commodity or asset. And this price is often called cash price, current price, or spot price. And the important thing to remember here is that it is the price for the immediate delivery of the good or asset. Moving to the third one, we have little r, or small r, sub f. And that is what we call the risk-free rate of interest, expressed as an annual rate. Oftentimes, you'll see it without the subscript f, but it'll be clear from the text that that is the financing cost and is risk-free. So either R or RF could be interpreted as the risk-free interest rate. Finally, the way we expressed the futures prices with the small f sub naught and in parentheses big T. So what this means is that this is the futures price today for a contract that expires at time big T. So remember that a futures contract is an agreement that two counterparties enter into to do something, either buy or sell something, an asset or commodity, at a future date at a fixed price. And that fixed price we call the futures price. And so the agreement has an expiration date, and that's why big T has to be there. And the agreement futures price is set at the time you enter into the agreement. And that time in the notation is the sub zero. So F sub zero, parentheses, big T, close parentheses, is the futures price today for a contract that expires at time big T. The second set of skills you need to solve these problems is pricing. And more than skills, you need actually the knowledge to be able to figure out the prices of these contracts. So you have to remember that in underpricing, the futures price is the cash price plus the cost to carry. And this cost to carry will be different depending on the commodity and will be made clear from the wording of the problem what it is. The second issue here is that the price for immediate delivery is the cash or spot price. This is something that we talked about in the previous slide when we talked about notation. Okay? And the third set of skills refers to, or within pricing refers to the rounding of the theoretical price to the minimum price fluctuation of the contract. Just to give you an example, the heating oil futures contracts minimum price fluctuation is 1/100th of a cent. So you can't have a price, a theoretical price for that matter, that is longer than 1/100th of a cent. So that is something that perhaps you won't see in an exam, but you will use in your practical life. Now that we've covered the two sets of skills that you need to solve this problem, why don't we go right at it and solve it? Let's work on the solution then. The answer is the following. Remember that the futures price, remember small f, sub naught, big T, that means it's the futures price established at time 0 for a contract with expiration, big T, is equal to the cash price plus the cost to carry. In this case, not in this case, but theoretically, basically, this is what or how you calculate the futures price. You multiply the cash or spot price by 1 plus the risk-free rate, which is compounded to the T, which is, remember, the time to expiration expressed as a fraction of the year. So this is the formula you have to apply to find out the theoretical or fair value futures price. Remember, the cash price or spot price was 69 cents per gallon. And remember how the prices are expressed. In this case, for heating oil, prices are on a dollar basis per gallon. The risk-free rate is 5%, and the time to expiration in this case is 60 divided by 365, or 0.16438. If you just replace these numbers in the corresponding formula, you get a futures price of 0.65556 per gallon. But remember that in practice, the heating oil contract has a minimum price fluctuation of 1/100th of a cent. You cannot find prices that have, let's say, fluctuations of less than 1/100th of a cent. So we have to round this price to the real world price that you would find in the market. And that is, you would round it to 4 decimal places, and the correct or rounded answer to this problem would be 69.56 cents for the theoretical price of a heating oil futures contract that expires in 60 days. Let's now change the problem slightly, and for this previous example, I'd like to ask you what the implied repo rate would be. Remember that the implied repo rate is simply the percentage cost to carry implied by the futures price. Now, in this case, you know what the implied repo rate is because I had you calculate the futures price with a 5% single financial cost to carry. So you know that the implied repo rate in this case would be 5%. But what if I gave you a market price and didn't tell you what the cost to carry was and you had to calculate it? So let's use the previous example as if we didn't know that the implied repo rate was 5% to calculate that implied repo rate. So